Okay, this is your grade 8 review of integers. This is your chapter review from chapter 8 in the Math Links 8 textbook, multiplying and dividing integers. Your first three questions are definitions. Question number 1 says integers include positive and negative whole numbers as well as what? And to be perfectly honest, when I first read this, I'm like, I don't know what they want me to put. But then I realized that the answer is 0. So any positive and negative whole numbers as well as the number 0. Question 2 says, when following the order of operations to evaluate this expression, what should you do first? Well, according to this, you have brackets here, so therefore you must do the brackets first. Your B in your bed mass. And finally, question 3, an integer chip represents positive 1 and an integer chip representing negative 1 are together. They are called a what? They are called a zero pair, which is funny because 2 of the 3 answers contain the word 0. Question number 4 says, what multiplication statement does each of these sets of diagrams represent, A and B? So if this question is given to you on your test, what you have to ask yourself when multiplying, are you adding groups or removing groups? And in the first question, A, you are adding 2 groups of positive 5, right? Or negative 5, sorry, negative 5. So adding 2 groups of negative 5 is your expression. And when you add 2 groups of negative 5 to something, you end up with a product of negative 10. In question number B, you start with 0 again, but this time you are removing 2 groups of positive 2. So removing 4 groups, not 2 groups, oopsie daisy. Removing 4 groups of positive 2, and when you do that, you end up with a final answer of negative 8. Question 5 says determine each product. Now on a test, if it says to determine each product but does not give you a method, which one are you always going to choose? Sign rules, number line, or integer chips? Sign rules, of course. So before I use that, if I look at the signs here, a positive and a positive, same signs, positive product. For B, different signs is negative. C, same signs is going to be positive. And D, different signs negative. So if I get the signs out of the way first, I can just do it that way. And then just worry about my products. 3 times 3 is 9, so positive 9. 4 times 5 is 20, so negative 20. 2 times 1 is 2, so positive 2. And 5 times 3 is 15, so negative 15 is your product. Question 6, a sloth took 9 minutes to climb down a tree. So if I think about this tree as like a number line, and here's the sloth up here. There he is up here. That's the world's worst sloth. If the sloth is climbing down the tree at 2 meters a minute, so let's pretend this is 2 meters. That's 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes. Oops, the tree has to get bigger. There we go. There is the 9 minutes to climb down 2 meters a minute. So 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 8 minutes, and 9 minutes. And finally, the sloth is down at the bottom. He looks like he died. He looks like he fell out of the tree. But he's at the bottom of the tree after climbing down. So it's 9 groups of descending 2 meters each time. So therefore, 9 multiplied by negative 2 is the expression that represents his descent, which is negative 18. So therefore, he climbed down 18 meters. Of course, down replaces my negative symbol, so I don't need to worry about, he didn't climb down negative 18. He climbed down 18 meters, or he descended 18 meters. Question 7, determine each product using a number line. So adding 3 groups of negative 6. So if I take my number line, since I'm adding negativity to something, I'm going to start at 0 because I'm going to be adding negativity. So 1 group of negative 6, 2 groups of negative 6, 3 groups of negative, oh, sorry, this is negative 12 here, and this is negative 18. So adding 3 groups of negative 6 will result in a product of negative 18, or a quotient, or a product, excuse me, of negative 18. And the second one, B, adding 4 groups of positive 2. Adding 4 groups of positive 2. So there's 1 group of positive 2, 2 groups of positive 2, 3 groups of positive 2, 4 groups of positive 2. Adding 1 group, 2 groups, 3 groups, and 4 groups of positive 2 results in an advancement of positive 8. Question number 8 asks you to calculate. So if given the opportunity to do however you want, you're probably going to use sign rules. So the first one, positive times a negative, I know that's going to be a negative. A negative times a negative, same signs, positive. Worry about my product now. 7 times 8 is 56. And 12 times 9. Well, 10 times 9 is 90. And 2 times 9 is 18. So if I combine those, I get 108. So my answer for question B is positive 108. Question 9 asks you to estimate and calculate. You'll have this on your test. So when you estimate, just round to the nearest, the greatest place value. So 22 is going to round down to 20. Positive 35 is going to round up to positive 40. 2 times 4 is 8. Plus 2 zeros is 800. In the next example, I'm going to use a negative 50 multiplied by a positive 10. 5 times 1 is 5. Add 2 zeros is 500. So for my estimations for both of them, that's what I would get. And if I calculate them, you can use a calculator, or if you're adept at the pencil paper, you can use that. 10, 11, 6, 6, 770. So for the first one, the calculation will be a positive 770. By the way, this is a negative 500. I forgot about that. And for the other one, 49 times 13, 27, 14, 9, and 4, 7, 13, 6. My calculation, so it's my estimation, it's my calculation, and it's my calculation. Question 10 says the product of 2 integers is negative 99. What could the integers be? So for this one, what you really want to know is, what are all of the different ways I can multiply to get 99? Or what are the factors of 99? So if I think about my 1 times 99, that's one way I could do it. I could also go 3 times 33, or 9 times 11. So all of the whole numbers that are divisible into 99 are these. All right, those are the factors. And if I want, what I can do is, if I had a positive 99, I know it would be 1 times 99, 3 times 33, and 9 times 11. But because it's a negative 99, I have to have different signs. So negative 1 times a positive 99 is one way to get negative 99, or reverse it. A positive 1 times a negative 99 is also another. I can do 3 times negative 33, negative 99, or a negative 3 times a positive 33. And of course, I could do a negative 9 times 11, or a 9 times a negative 11. So any of those 6 answers are valid. Remember, integers can't be decimals. They have to be whole numbers. So somebody in the other class said 49.5 times negative 2, right? But in order for an integer to be an integer, it has to be a whole number. Question 11 says, Kenji spends $5 per week to buy a sports magazine. Represent the amount he spends in a year by integer multiplication. So if he's spending money, we're going to think of that as being a negative effect on him. So we're going to think of the cost of a magazine as being negative $5. If it's $5 per week and he wants to be per year, the first thing I'm going to do is, there's 52 weeks or 52 groups of spending $5. That's the expression that represents how much he spends a year. And if I work that out, it would be negative 260. So therefore, Kenji spends $260 per year. Now, an interesting point here. You can't have this. It's not negative 5 groups of 52. It's 52 groups of negative 5, right? So you have to make sure you put your integers in the correct order when you do that question. Question 12 talks about integer division with modeling. Use the diagrams to complete it. So here we have positive 10. And when we look at what they did here, there's two interpretations. I divided it into two groups. So positive 10 divided into two groups means there is positive 5 integer chips in each group. In the second interpretation, I had positive 10. I divided into groups of positive 5. How many groups could I make? I could make two groups. So either way you interpret it, both of those division statements are valid for that drawing, and you should be able to give both on a test. In the second example, I have negative 8. I divide it into groups of negative 2, groups of negative 2. How many groups can I make? I can make 1, 2, 3, 4 groups. So negative 8 divided into groups of negative 2 would be 4 groups. And finally, negative 8 divided into 4 groups. How much would be in each group? There would be negative 2 in each group. Question 13, determine each quotient. Since it doesn't give you number line, integer chips, or sign rules, only a buffoon would choose anything but sign rules. So if I'm dividing them, I know same signs positive, different signs negative. So I'm going to first put my signs down using that sign rule. And then I'm going to focus on the quotient of each. 16 divided by 8 is 2, so positive 2. 14 divided by 2, so positive 7. And 2 divided by 2 is not 0, but 1. So my answers are positive 2, positive 7, and negative 1. Question 14, write a word problem you can use to solve the expression negative 14 divided by positive 7. So it took a sloth. No, that's not a good one. I owe $14. I owe $14. I owe $14. And I want to divide them into 7 manageable payments. I want to pay off my debts in 7 days or 1 week. Divided between the 7 days in a week. How much do I have to pay off to have my debt done in a week? I would have to pay off $2 per day in a week to pay off my $14 debt. And there's infinite variations of expressions you can use, but that's the one I'm going to use. Question 15, determine the answer to this using a number line. So if I take this and say I have negative 18, so I'm going to put down negative 18 here and 0 here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's not bad. So if I have negative 18 divided into groups of negative 3, that's how I'm going to interpret this one. Dividing it into groups of negative 3. There's 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. If I have negative 18 divided into groups of negative 3, how many groups can I make? I can make 6 groups. Question 16, without evaluating the quotients, identify the greatest quotient. So if I just use what we've been doing so far in the video, just calculating signs, a negative divided by a positive will give me a negative quotient. A negative divided by a negative, same signs, positive quotient. And a positive divided by negative, opposite signs, negative. So based simply on sign rules, I know there's only one answer that's going to have a positive answer. So therefore, the division of those two numbers, regardless of what their actual quotient is, will yield a positive answer. Question 17, calculate. So I'll go get my signs first. Same signs, positive, different signs, negative, same signs, positive. 75 divided by 25, $75 divided between groups of 25, you get 3 in each. 8 times what is 64? It's 8, so negative 8. 5 times what is 85? 3 less than 100, which would be 17. And 88 divided by 11 is 8. Question 18, if two integers have a quotient of negative 1, how are the integers related? For this one, if you think about division of two numbers, if I just said it equals a positive 1, what do we know about those two integers? They must have been the same. Positive 2 divided by 2 is 1. 10 divided by 10 is 1. Negative 3 divided by negative 3 is 1. In all of those instances, we have a quotient of 1. However, if it's negative 1, the only difference between those numbers is the signs, right? Here the signs are the same, but if I reverse them, 1 negative, 1 positive, I would end up with a quotient. So what is the relationship between a positive 3 and a negative 3, or a negative 10 and a positive 10, or a negative 2 and a positive 2? Well, the relationship is they are opposite integers. They are opposite integers. And what that basically means is they were equidistant from 0 on a number line, right? If a number has its opposite, it is the mirror reflection of itself across a number line where 0 is the middle. Question 19, 6 friends visited a zoo. The total cost of admission was $90. One of the group was celebrating his birthday, so the others agreed that he should not pay. How much did the others pay? So we have a cost of negative $90 to go to the zoo. It's going to cost $90, so we're going to express that as the integer negative 90. Divide between not 6 friends, but rather 5 friends. So the expression that you can use to calculate the cost of each is that. When I work that out, it's going to work out to be negative 18. So therefore, each friend spent, and the spent is going to be what the negative sign represents, $18, period. Each friend spent $18. Question 20 is a bedmass question. The square brackets I don't like because they don't make them very good here, but I'll make them a little bit bigger. So we're going to follow order of operations. The first thing I'm going to do is my bracket, so negative 3 multiplied by, and notice how I did away with the multiplication symbol just by putting negative 3 outside the bracket. I'm going to keep flip change to get a positive 6. So my next line of my bedmass will be this. I'm left with a multiplication and addition. I'll do my addition first. And then, make a little bit more room here. The sum of negative 18 and 12 is negative 6. So notice on your bedmass, each expression is slightly smaller, but has the same value. Each of those levels, this level, this level, this level, and this level, all have a value of negative 6. In the second example, I'm going to do brackets first again. So 12 divided by 5 take away 8 is not 3, a common mistake, but if you take away more than you have, you end up with a negative value. So my first simplification is brackets. My next is going to be division and multiplication. Now some of you might want to do division and multiplication together. Some of you just like to take it one step at a time. No problem if you do it this way. Make sure you understand that this is a subtraction symbol, not an integer symbol, and that this expression is the multiplication symbol. Multiplication, that's the answer there. So make sure you keep subtraction symbols and integer symbols separate. And then finally, the sum of these two will be negative 4 and positive 8, which is a positive 4. Question 21. The sum of 6 integers is negative 42. What is their mean? Well, in order to know what the mean is, the mean formula is the sum of numbers divided by the number of terms. And that's how you get the mean or the average of something. So if I know that the sum of the integers is negative 42, then the sum of the numbers I can erase up here, and I can put, since it told me, negative 42. And since I know the number of terms, according to the preamble, is 6, I can put a 6 there. So if I think about negative 42 divided by 6, that is going to be negative 7, which means the average, or the mean, is negative 7. And do you have enough information to determine what the first 6 integers must have been? The answer is no, I can't, because there is infinite possibilities of integers you can add together to get the sum of negative 42. You could have 1 plus 1 plus 1 plus 1 plus 1, that's 5, plus negative 47, that's 1. You could have 2 plus 2 plus 2 plus 2 plus 2, which is 10, plus negative 52. That will also give you a sum of negative 42, and there's infinite variations of that that could have a sum of 6 integers that equal negative 42. Question 22, over a 5-year period, the number of Manitobans living on farms decreased from this to this. So this is a tricky one. because it's decreasing, I'm going to take where it ended, take away where it started to represent the decline. If I reverse it, it appears rather than declining in population, it's increasing in population. Divided between the 5 years, this is going to give us our average change per year. I'm going to use a calculator to say, oh, I already had it in there from before, look at that. So if I go over here, 68,135, take away 79,840, which it used to be. The difference in population is going to be negative 11,705 divided by 5. So it decreased in population by 11,000, almost 12,000 people. So if I take that number and divide it between the 5 years, negative 2,341 is the average number of people in Manitoba living on farms that decreased. So therefore, the average decline is 2,341 per year. Okay, the average decline in population on people living on farms in Manitoba is approximately 2,341 people per year. Your second last question is 23, where it says a small aircraft descends at 90 meters at 3 meters a second and then descends at 80 meters at 2 meters a second. For how much time did it descend altogether? How many of you tried to draw a picture first? Okay, if you did or didn't, it's a good idea whenever you have to wrap your head around the context of a story problem to do your best to draw it. So I'm going to draw the airplane. That's my airplane. And it descended 90 meters. So it descended 90 meters at a rate of 3 meters for every second. Okay? So if I think about this, descending 90 meters divided by the 3 meters, sorry, not negative 3, the 3 meters per second. That means it must have taken me 30 seconds to descend that 90 meters, right? If it descends 3 meters a second and it's gone down 90 meters, that means it must have been 30 seconds to go down that. And then it went down a further 80 meters at a rate of 2 meters per second. So again, our descending of 80 meters for 2 meters every one of those seconds, it must have taken 40 seconds to descend that much. So altogether, we would have 70 seconds to go down the 170 meters. Or, as one expression, 90 meters divided by 3 combined with 80 meters divided by 2 will equal 70. Now, if you are intelligent, you could also say 70 seconds is the same thing as 1 minute and 10 seconds, if you want to get real nerdy, right? Or you can make it into a fraction. So 70 seconds out of 360 seconds, no, sorry, out of 3,600 seconds in an hour, break that down into a 7 over 360th of an hour. You can get real nerdy if you want, but if you want, 1 minute and 10 seconds is a great answer. And finally, your last question, 24, says a fitness club charges its members $250 a year. If a member makes a single payment to pay for the next 3 years, there was a discount of $5 per month. How much is a single payment? So we think about $250 a year. So I'm going to take 3 payments of $250 a year. That will be the cost if there was no deduction, correct? He would pay $250 a year for 3 years. That would be the cost. However, it is not $250, is it? If you pay for those 3 years, that $250 will be decreased by a discount of 12 months of a discount of negative $5 each of those months. Once you look at that expression, and I'll guarantee you none of you had that written, so let's think about this expression, Keegan. 3 years of a payment of $250 plus each of those $250 payments will be deducted by a $5 a month discount, right? So if I write out this expression, that'll be 3 years of 250 plus a negative 60. What will each of those years cost if there's a $60 discount? 3 years of $190 cost each year, correct? Which will mean, when I work it out, therefore, the final cost for 3 years will be $570.